Alright, today we're going to be dealing with something called the unit circle and the idea of radians. In the math world, when we deal with the math world, and you start working with mathematics and upper level mathematics, up till now we've dealt with the idea of angles and degrees. All throughout your mathematical career, everything you dealt with respect to your angles was always in degrees. Problem we have when we get to upper level mathematics into the calculus world, angles start, and we start doing higher level calculations, angles in degrees start to fall apart. So what we have to do is we have to be able to come up with a different way of being able to handle our angles and deal with the angles and restate our angles. And that's the idea of radians. Okay? When dealing with radians, we deal with something what is called a unit circle. And when you have a unit circle, it's a circle of 1 unit. Now it could be 1 inch, 1 foot, 1 mile, 1 yard, 1 centimeter, 1 meter, whatever units you want. It's just 1 unit. So we have a circle with just 1 unit, a radius with just 1 unit. And if we look at the idea for circumference, the circumference of a circle is defined to us as, hopefully remember this, the distance around the circle. Something you learned back in the geometry world, and even prior to that in the elementary world in mathematics when you got to 5th and 6th grade, and 7th and 8th grade, you dealt with that. You dealt with geometry. Circumference is the distance around the circle. It's the perimeter for a circle. It's a perimeter for a circle. And that should be something that you're familiar with. Well, when you're talking about the idea of a radian, a radian is an arc length on a unit circle for a specific central angle. It's the portion of the circle in the interior of the central angle. The arc length on a unit circle for a specific central angle. It's the portion on the circle of the circle in the interior of the central angle. Okay, so we introduced some terms here that you may not be quite you may not quite remember, but when you talk about the arc length on a circle, that is the outer edge. It is the outer edge of the circle. It's the measurement on the circle. Now, if we take a look at the definition of a circle, when we define the idea of a circle, it is a set of points that are equal distance to a given point. So when you take a look at a circle, you have this given point, which we call the center, and this set of points that lie in equal distance from that center point is the idea of a circle. It's the outer edge of the circle. Okay? It's not the good stuff when we're eating a piece of pizza. Okay? When we're eating pizza, we like to look at the interior of the circle because we like to eat that. But the outer edge is, you can think about it as just like the outer edge of the crust of a piece of pizza, or a pizza that you're eating. And then the other term that we bring back is something that you learned in geometry, is what is called a central angle. A central angle is an angle whose vertex is at the center of the angle. So just going back to your ideas of geometry, you looked at the idea of a central angle in geometry, and you did some calculations with the central angle. That central angle, the vertex point is at the center point of the circle. So if I look at the vertex point up here at the center, if I look at two rays that I can build off of that, when we talk about this arc length, in the interior of the central angle, this is your arc length. This is also the idea of radians. This measurement from here to here in the interior portion of the central angle is your arc length, and that is your number of radians. Well, if I'm talking about a unit circle, first off, how do we determine the circumference of a circle? Well, you have two choices. You have pi r squared, or we have 2 pi r. Well, to find the circumference of the circle, we can go 2 pi times our radius, or we also write this sometimes as pi times diameter. We're going to deal with more than 2 pi r. But it doesn't really matter, because if we take a look at a unit circle, the radius is a value of 1 unit. So we have a value of 1 here with our radius, or we have a 2 with the diameter. So our circumference for a unit circle is 2 pi units. Now, we all know, hopefully know by now, that pi is a value of 3.14157182182, blah, blah, blah. Everybody knows it. If you look at your calculator, upper right-hand corner, or upper right side of your calculator, you can have a pi button there. You can get the pi value there. So we tend to just leave things in terms of pi here and not really multiply this out. And that's fine to leave things in terms of pi. Okay? And oh, by the way, next week we got pi day. So if we take a look at a circle here, we're going to call this a unit circle, which means this is a point 1, this is a point, this is 1, this point here is a -1, this down here is -1, this would be a unit circle. And if we assign some ideas of degrees to this, if we would spin, this has been our 0, all the way around the circle. So if we start here, and we have our initial or terminal side of our angle, and if I would rotate this angle all the way around the circle, well, what we've learned up till now is this is 360 degrees. And if we take a look at the arc length of the interior of that circle, what we're looking at here is we're looking at this entire arc length right here, all the way around the circle, which is the circumference of the circle. So our arc length is 2 pi, but this is also our number of radians. So if I go 360 degrees, this is equal to 2 pi radians. Well, if we take an angle and only rotate it 180 degrees, this is a little bit easier to see, because we could take a look at just this portion of the circle. This would be in the interior of our central angle. Well, if we rotate this 180 degrees, how many radians would this be? Well, if we rotate the whole way around the circle, that was 360 degrees, that was 2 pi radians. So if we would just only go half of the circle here, how many radians would that be? Well, we could take our 2 pi and divide it by 2 because we're only doing half of the number of radians. So this is equal to pi radians. So if we have 180 degrees, we only go pi radians. Well, what if we only went 90 degrees? So we just rotate from here up to here. Well, this would be 90 degrees. What would be the number of radians we would have with 90 degrees? Well, if 180 degrees was pi radians, 90 degrees is half of 180 degrees, so this would be half of pi. So we could say 1/2 pi radians, or what this is typically wrote as is pi over 2 radians. Oopsie. Problem there. Let's try that. There we go. Well, if we went 60 degrees, how many radians would we have with 60 degrees? Go back to this. What do we have to do to 180 degrees to get to 60? Math, multiplication, or division? Typically division. What could we divide 180 by to get to 60? Well, we divide that by 3. So this would be pi over 3 radians, because 180 divided by 3 is 60. 45 degrees, 30 degrees. What can we do to 180 to get to 45? What can we do to 180 to get to 30? This would be pi over 4 and pi over 6 radians. So if we take a look, there's a proportion that we can use that can convert any radians into degrees and degrees into radians. And the key idea here is pi radians is equal to 180 degrees. And once again, this is a ratios and a proportion. This will equal x number of radians over theta number of degrees. And if we utilize this, we can always convert anything from radians to degrees or degrees back to radians. Another key idea to remember in conversions, pi radians is equal to 180 degrees. So if I had the value of pi in here, I could take 180 degrees and divide it by 3 and come up with a 60 degrees. 180 divided by 6 to get 30 degrees. And 180 divided by 4, 45 degrees. So if we look at 150 degrees and want to change it to number of radians, we have pi over 180 is equal to x radians over 150 degrees. Now typically we want to leave these things in terms of pi. Solving a proportion, we can cross multiply. We have 150 pi over 180 is equal to x. And we can reduce this fraction down, take out your zeros. 15, we can take 3 out of top and bottom. So we have 5 pi over 6. You can also clickety-clack into your calculator, 150 divided by 180, hit your math button, hit enter, and it will give you your 5/6. You can have 5 pi over 6. Go ahead and do the next 3. Check your answers with somebody around you. 200, 50, 300. Follow the same method of madness. Do those problems and check your answers with somebody around you. So looking at these, we have pi over 180 is equal to x over 200. Multiply by 200, 200 pi over 180 is equal to x radians. Take a 0 out, we can take 2 out. So we should have 10 pi over 9 here. Pi over 180 is equal to x over 300. So we have 300 pi over 180. Take the zeros out here. And then we take 6 out of top and bottom. So we have 5 pi over 3. And lastly, we should have pi over 180 equals x over 50. 50 pi over 180, zeros cancel out, 5 pi over 18. Easily we could deal with this by, if I'm changing in degrees, just taking the 180 and substituting in. We have 180 divided by 12, which should give us 15 degrees. 2 times 180 divided by 3. You could also use some mental math with this. Take your 180 divided by 3, which will give us 60, and go 2 times 60, 120. Likewise, 5 times 180 divided by 3. I can get 60 out of this, multiply by 5, 300. Go ahead and do the last one. So we have 9 times 180 divided by 4. They give you 405. Now what you'll be asked to do in your homework, you'll be asked to find exact values. So you'll be asked to find maybe the cosine of 2 pi over 3. My suggestion to you is change it to a degree mode first, because radians are a little bit iffy for us as we go along because it's something that's new to us. So why not make life a little bit easier on ourselves? 2 pi over 3, we have pi over 3 is 60 times 2. This is the same as the cosine of 120 degrees. So now you can do your 120 degree triangle. reference angle is 60. Negative with that, so we have a negative 1/2. So when you're asked to find trig values of them, go ahead and change them in degrees, bend the rules a little bit. Bend the rules, make it a little bit easier on yourself, and go ahead and complete the problem by dealing with them in a degree mode. Sorry I missed the last couple days, but sorry I've been sick. Hopefully I'll be back on Thursday. That's a hope, if everything goes well. If not, I'll see you on Friday then. All right, everybody have a good day. Thank you for cooperating.